In this video, we're going to review oxidation-reduction reactions and then apply oxidation-reduction reaction principles to see how batteries work. There are many important oxidation-reduction reactions, and you probably have these common oxidizing agents at home. An oxidation-reduction reaction involves the transfer of electrons. So a substance that's being oxidized loses electrons, whereas a substance that's being reduced gains electrons. Oil rig is a good way to remember that oxidation is losing and reduction is gaining. That is, electrons. Metals lose electrons to form positively charged metal ions, that is, cations. And it turns out that different metals have a different ability or activity to lose electrons. Okay, so stop the video and answer these 3 questions which have to do with the activity series. And here are the answers. So the more active metal is the metal that more easily loses electrons. When copper metal is placed in the zinc ion solution, no reaction occurs because copper is less active than zinc, which means that copper does not want to give up its electrons. When the more active zinc metal is placed into copper ion solution, a reaction does occur because the zinc metal wants to give up its electrons. So zinc loses its electrons to the copper 2 plus ion. The copper 2 plus ion is reduced to copper. And we see copper metal plated onto the surface of the zinc. So these experiments tell us that zinc is more active than copper. This is the activity series of metals. The metal at the top, lithium, is the most active metal, which means it most easily loses its electron. Gold is the least active metal, which means it does not want to give up its electron. Note that the metals can be oxidized to metal ions. That means the metal is a reducing agent because it can be used to reduce something else. Also note that each reducing agent has a corresponding or partner oxidizing agent. For the strongest reducing agent, its partner oxidizing agent is weak. For the weakest reducing agent, in this case gold, its partner oxidizing agent, gold ion, is strong. Here's how we can use this table. A reducing agent reacts with any oxidizing agent below it on the table. We can use this to predict the products of an oxidation-reduction reaction. In the previous slide, we saw that zinc reacts with copper 2 plus ion to form copper metal and zinc 2 plus ion. So the oxidizing agent has to be strong enough to react with the reducing agent. Note that lithium ion is not a strong enough oxidizing agent to react with zinc. The standard reduction potential table is really an activity series with numbers. The numbers refer to the standard reduction potential. The standard reduction potential is related to delta G, the change in free energy. So if the reduction potential is negative, that means delta G is positive and that reaction does not occur. That is, it's not spontaneous. So stop the video and let's apply these ideas to answer these questions. And here are the answers. Note that this reaction has a positive reduction potential. That means delta G is negative, which means that reaction occurs, gold would rather be gold metal. For this reaction, note that the reduction potential is negative. That means delta G is positive. That means this reaction doesn't occur. Potassium ion does not want to gain an electron. Potassium ion prefers to stay as it is. And as you mentioned in the previous slide, if the reducing agent is strong, its partner oxidizing agent is weak. Many common reactions are oxidation-reduction reactions, so stop the video and check around your house to see if there's any oxidizing agents or reducing agents or both at home. So here are the answers. You probably have some bleach and hydrogen peroxide at home. And maybe you have vitamin C, which is a reducing agent at home too. Bleach, hydrogen peroxide, oxygen, and iodine are 4 common oxidizing agents. So stop the video and identify which one is the strongest oxidizing agent, which one is the weakest. And here are the answers. The standard reduction potential table gives us the answer to that question. Remember that E is related to delta G. So the more positive E is, the more negative delta G is. And the more negative delta G is, the more spontaneous the reaction is. So hydrogen peroxide has the largest E, that makes it the strongest oxidizing agent. Iodine has the smallest E, that makes it the weakest oxidizing agent. Gold is an inactive metal, which means it doesn't want to lose its electrons, which makes gold very unreactive. So stop the video and identify which oxidizing agent will oxidize gold. And here is the answer. The reduction potential of gold ion is between hydrogen peroxide and bleach. So hydrogen peroxide will oxidize gold, but bleach, oxygen, and iodine will not. Remember that an oxidizing agent will react with a reducing agent below it on the table. And here's the math. Aqua regia is another substance that dissolves gold and other inactive metals. Organic aqua regia selectively dissolves noble metals. And cyanide is used to mine gold. It involves the formation of the soluble complex ion.